Well, hello everybody, and thank you for joining this webinar that is about to begin. My name is Ilkka Turunen. Glad you could all make it. I work as a solutions architect for a company called Sonatype, and personally in charge of our solutions architecture for our customers here in the EMEA region. Now, we here at Sonatype have been working with something called the software supply chain for almost a decade now. We are the company behind one of the largest build tools in the Java ecosystem, and we actually run the background library for this tool, something called the Maven Central Repository. The Maven Central Repository is the largest collection of open source artifacts for the Java ecosystem on the internet, with about 52 billion download requests last year. In addition, we sell tools and products that help companies accelerate the usage of their software supply chain, and we're very active within the community. So in my presentation today, what I want to do is share some lessons that we've figured out by running a few community efforts alongside with other companies in this ecosystem. My presentation today will kind of share some light about what modern software development actually looks like, and what are the best running companies doing in order to stand out amongst their competitors. The outstanding lesson today is that quality should be built into production, and that is how you're going to be able to manage the software supply chain. My presentation is based on two community pieces of reports that we published over the years, the State of the Software Supply Chain and the State of DevSecOps 2017, both of which are cross-company, cross-community collaborations that have gathered data from from practitioners and from best-performing companies across the world. Well, without further ado, let's get started. The truth is, nowadays, software has eaten the world. In fact, in the application economy, companies that build great software will own the future. The truth is, software has seeped into every single part of our lives, and more often than not, software is the competitive differentiator between one company to another. Just take a look at any car driving down the road nowadays. It will most likely have more lines of code than your average iPhone. Well, in this new application economy, companies have been striving to create better software faster for many, many years now. In the 1990s, we had waterfall development with strictly defined regimens. In 2000s, in the quest for more speed, we started looking at things like agile and lean manufacturing. We took a lot of pages from the lean manufacturing that occurred at Toyota and that its innovators, W. Edwards Deming. And most recently in 2015, most companies have at least started looking at this thing called DevOps. So we could say that modern software development is a mixture of DevOps native development and management styles. But regardless of how companies develop software, the one thing that remains is that companies need to develop software faster. And the companies that build the greatest software the fastest will eat the world. Well, one of the first lessons that we've learned over our decade of managing this open source ecosystem is that companies actually don't write their own software anymore. Instead, they use billions and billions of different parts from various different open source communities and actually assemble their software from these bits of other pre-manufactured software. In fact, according to our research, the modern enterprise application will be about 80 to 90% assembled components of open source bits and pieces put together. For example, a framework, a few libraries. Why would you reinvent cryptography yourself if you can use something that's been developed by people who clearly know what they're doing? And only about 20% of your standard application will actually be original in-house developed code. everything else that companies build is actually assembled based on these pre-manufactured pieces. There are various different ecosystems that help you do this. Things like Ruby Gems, the Docker Hub, npm.js, Bower, Maven in Java, NuGet in the .NET world. But what is consistent across all of these ecosystems is no longer is software built from scratch. It is actually assembled to a certain point out of these components, and only what your developers actually do is they only fill in the blanks. Well, one of the things that we do see across all of these companies as we've created our reports is the best organizations out there recognize that they have these software supply chains and that they are a part of these software supply chains in some aspects. Now, supply chain management is something that W. Edwards Deming really spoke about quite heavily, and the best companies that perform the most highest in terms of maturity and survey measurements tend to be borrowing from Deming's playbook. First of all, they standardize against using too many open source components or different projects. The analogy that I like to say as a software developer is, would we want to use 100 different logging frameworks, or should we think about standardizing against a few different logging frameworks? A car manufacturer wouldn't necessarily have 100 different types of brake pads. They would find a few trusted suppliers and use those across all of their different models. The second lesson that we found is that the best only use components of the highest known quality and don't necessarily depend on just any project that they find on GitHub. Instead, the best performing companies had a level of quality assurance and a level of policies to make decisions about which open source projects they should be using within their own products. And finally, the best companies such as Intuit and Capital One tended to continuously track when and where their components were used, because truth is, time goes on, and various different since we have various different components within our applications, what can easily happen is that one or two of those open source components go bad. So continuous monitoring and tracking is highly necessary to ensure that we know which ones are going bad, and in order for us to execute recalls and retakes as well. The truth is, not every open source component is created equal. Some are healthy, some are not, and the truth is, most of them go bad over time. Software. We have a saying within my company: software components don't age like fine French wine. They don't get better with age. Instead, they age more like milk. For a long time, they're good. They can easily be. There are projects that are tens of years old that still are pretty good and pretty stable. But one day someone might find an issue in one part or another of these components, and when that point happens, you have to know what to do in order to remediate that issue. One of the biggest things that we wanted to bring in these pieces of research that we published is that we wanted to make these invisible effects visible. So we wanted to make sure that companies understood the fact that there exists this software supply chain, and that they actually need to have the ability to understand and manage those in order to be competitive in the modern marketplace. So I've said this term software supply chain quite many times, but what does that actually mean? Well, the truth is, it's really just an allegory to the traditional notion of supply chains that people use in manufacturing today. It has the notion that in assembling final goods, we use these pre-manufactured components. Well, those pre-manufactured components come from suppliers, or in our case, open source projects. Many companies have some sort of binary warehouse inside of their own company, and they rely on open source warehouses spread around the internet in order to keep track and catalog and retain a copy of the components that they are using. Many companies are able to store and distribute these components in this way, and examples of these large warehouses include things like Ruby Gems, PyPy, the Maven Central Repository, the NuGet Gallery, and loads of these other things that I mentioned earlier. And using these various different components, we finally arrived at finished goods. And the truth is, the variety and volume of open source components in the world is growing exponentially. There's a really interesting site called moduleaccount.com. It really has quite a simple value. It kind of keeps track of the number of different components or packages that are available across various different development languages from all of these previously mentioned ones. And it shows the increase in the number of these components that are available to the developer ecosystem and to the developer population over time. So we used some of this data from this site to kind of see that over 1,000 new open source projects were created every single day. That's people delivering a new kind of software, a new piece of raw materials that may be used in larger contexts, or they might be very, very large projects. 1,000 new projects per day. Across all of those projects, 10,000 new versions of existing projects were being released every single day. But from looking at the general population of all the different open source projects worldwide, this is the number that we came up as an estimate. There's a huge supply of these components entering the ecosystem and available to our own personal software supply chains. When we look at the central repository that Sonatype manages and that we run, or Maven style Java open source components that we host in Maven Central, we looked at over 380,000 open source projects and found that on average these projects were releasing about 14 new versions of their components every single year. That's really great from a supply chain aspect, that the suppliers are very active and releasing new software very actively and kind of releasing new different kinds of innovations. Because it means that they are actively improving the software that they are at the same time making available to developers worldwide. The truth is, there's various different types of ecosystems, and for example, Docker is one of the ones that is on everybody's lips. So it's not only in the Docker, in the software production ecosystem that these kinds of supply chains exists, but also in the operations space. For example, Docker has seen tremendous growth, about 3,000% growth over 2 years has happened in the amount of Dockerized apps found in the Docker Hub. And official repositories only account to 20% of all different image pulls. So there's even more of a hidden ecosystem of supply chains of these manufacturers and producers that produce your base containers that then get used to build your own containers that then get your own software put into those containers. One of the things that we've been seeing as custodians of Maven Central is that the amount and volume of downloads just keeps increasing every single year. In 2016 alone, like I mentioned earlier, we saw over 52 billion downloads hit into our Maven Central repository. Now, the year before, in 2015, this number was 31 billion, and the year before it was 17 billion. So year over year, we see that, especially in the Java ecosystem, the amount and usage of open source is growing almost at a tremendous kind of hockey stick pace. And not only is it Maven that has this issue or has this positive issue, it's also present in the NPM ecosystem. NPM being the largest ecosystem for the JavaScript world. They actually experience 1.6 billion downloads per week, and every single year they set a new download record for more and more modules that are being downloaded. In fact, they have almost 6 million total users across the world downloading these components. Again, the same story occurs in the Python world, where PyPy.org actually hit their download records monthly as well. They got over 4.4 billion download requests. So across the development ecosystem, and no matter what language your company or your customers develop in, this phenomena is the same. Everybody is increasingly using these pre-manufactured components as a part of their development supply chain. However, one of the biggest discoveries that we've had for quite some time as proprietors of one of these repositories that has these boggling numbers is that not every single component, unfortunately, are created equal. Not every single part that is out there is equal in terms of quality, is equal in terms of licensing or even security. For example, what we can do is we can look at what we did was we looked at the download defect ratio for these Java components, meaning we measured year over year and looked at how many components that were being downloaded had a known documented security vulnerability. The good news is this number is getting smaller year over year. So as developers and companies become more aware at the fact that not every component that you download is free of all vulnerabilities, companies are developing and having measures to stop these bad components from coming in. But the fact still remains that about 1 in 16 of every component download has a known security vulnerability in it, even in the numbers from last year, which is 5.5%. When we looked at various different organizations, about 3,000 of them, we wanted to dive into what does this really mean for your organization in particular. In some sense, who cares if there's 31 billion components and 5.5% of them are vulnerable, because your particular organization might not be downloading that many. Well, we looked at these various different types of companies and what they were consuming. We started finding these average patterns. We found that the average company or average organization downloads about 229,000, almost 230,000 different times per year. So that means that they had 230,000 almost download requests that they consumed. Well, when we then started looking at the specifics about what those download requests actually look like, one of the interesting things was that there was only just over 5,000 versions of all the different components that they were being downloading. That means that they were downloading the same component several different times in various different sessions. But interestingly enough, when we boiled that down to unique components, we found out that the average company actually has downloaded 2,000. Just over 2,000 unique different components from various different individual suppliers. One way to think about this is, I've decided not to write this piece of software for my application. I've outsourced it effectively to an open source project, and I'm consuming that into my organization. There's a massive benefit to doing that because I didn't have to write that code, and it was freely available to me. But you do see some inefficiencies within these practices, that those over 2,000 components, if you remove all the different versions of those you are consuming, you've downloaded those over 100 times each on average. We do see some inefficiencies there, which we could work on building into software supply chains and making them more efficient that way. Well, from a security perspective, as we mentioned before, not every one of these components were created equal. One of the things that we found within these 3,000 organizations was that 17,000 of their component downloads had known vulnerabilities, or nearly 7.5% of those downloads had security vulnerabilities associated with them. Again, this is something that we want to bring to light to organizations. most organizations, when they see our data from the previous year's report, said, I had no idea that we were consuming this many components. I knew that we were downloading some, of course, and that we are using open source, but I didn't really stop to think about that volume itself. And when I look at these particular quality aspects, security being one, I'm somewhat surprised that by the number that we would be consuming, and maybe we should have some better practices around that. The truth is, part of those practices are how much hygiene we are building into our software supply chain. Well, the report that we produced last year allowed us to get a little bit of visibility from the downloads from these central warehouses. 6% of which were known to be vulnerable to also to components that were being stored in local repository managers of these target companies. A repository manager, if you don't know, is a local warehouse, if you will, for all the component parts that will be used by developers. It's kind of like a cache where these things get stored. And when we looked at the contents of those local warehouses, we found out that the security vulnerability defect dropped a little bit to 5.6%, which is good. But the surprise really was to us when we looked at the finished goods themselves and found out that the number actually increased a little bit. When we looked at the final applications that were being shipped out, 6.8% of the components in there had a known security vulnerability. Meaning that if there is any sort of quality or vetting of components between downloading them and putting them into an application, that probably isn't working as optimally as it can be. In fact, there's probably some sort of selection bias there that increases that ratio ever so slightly. Well, one piece of supporting evidence is a paper that was recently published by some researchers from the Northeastern University in the States. It's called "Thou Shalt Not Depend on Me: Analyzing the use of outdated JavaScript libraries on the web." He found what this interesting piece of research did was they looked at various different websites on the internet and found out that almost 40% of them included one library that had a known vulnerability. Popular libraries on front-end sites are things like Handlebar. 87% of them, of the inclusions of handlebars, were using a known vulnerable version. Almost 40% of jQuery versions out there embedded on websites had known vulnerabilities. And the same number stands for the Angular inclusions as well that were found in this piece of research on the websites. What we see in this space is that web developers often not only use these as in raw form, but they also modify these libraries by reformatting, restructuring, or appending code to them, which makes it a little bit harder for companies to detect the library usage in the wild. And the truth is, in this kind of jungle, almost 4 in 10 out of every single company don't have any source of open source policy in place. In fact, when we asked this in the 2017 DevSecOps community survey, do you have an open source policy in place for your company? We saw no increase between 2014, when we first asked this question, and 2017. So almost 40% of all companies still have zero consideration about which source of open source components they should have, and whether or not they should be using some sort of less vulnerable versions of those components. And that's quite a staggering number, considering the fact that this is not a new issue. This has actually been reflected in various different pieces of legislation, various standards, various different other forums as well. So that's just an interesting statistic to share. So on the flip side of it, companies are, 6 in 10 companies have done something. They've kind of understood that they operate within this supply chain and at least have some sort of policy in place to start to control that, which is the perfect first step for this issue. Well, what can you then do in order to manage this supply chain? Well, And when we started looking at these components and we started looking at, which components have security defects, which components are better, of course, often the question of, what version of a component is the best. Well, we looked at over 25,000 different applications provided to us by various different means. And not only do we look at those security vulnerabilities inside of there, but we kind of recognize that there is a relationship between the age of the components and the security vulnerabilities that you find in those components. So let me walk you through this, what this particular chart really tells you. It says that applications that we analyzed that had different components that were used, those components had varying ages from 1-year-old components to 11-year-old components. You'll see in year 2, for example, just over 20% of the components in all of these applications are 2 years old. 1-year-old components may make up maybe 18% of the overall application footprint. In those particular applications, you'll see that the red line within the report have a defect density or security vulnerability hovering just over 5% there. When you look at these components that are 6, 7, 8, or 9, or 10 years old within this analysis, you actually kind of start to see that the defect density actually rises to almost 15%. So if you have an older component, the inflection point being 6 years, the likelihood of having a security vulnerability within those components jumps up to almost that 15%. So if there is a lesson to be gleaned in here, is let's use the newest version of those components versus using older ones, because by year 3 we start seeing a huge jump in this defect density. And not only is it defects that are the issue, it's also that the older of a version, the older the component is with the latest version, the less likely it is to get any new updates. When we looked at these 25,000 different scans, we found that versions that were 7 years or older made up approximately 18% of the component footprint. For these older components, analysis showed that as many as 23% were on their latest version, meaning that the open source projects for these components were completely inactive or completely dead. The thing is, discovery of components with known security vulnerabilities or other defects used in applications is not something that anyone really desires. Unfortunately, when these defects are discovered in older components, chances of that issue being remediated by the projects by upgrading to a newer version is greatly diminished if there is no newer version. If a newer version does not exist, pretty much your only two choices are, you either keep that component and live with the risk, or switch to a newer component that might or might not be like the project that you were using, which means that you probably need to rethink about some of the functionality that you've implemented, and that accounts for a huge amount of technical debt and a huge amount of spike work that you have to perform that doesn't necessarily bring any new value. So it means that none of these options really come without a significant cost on impact or quality. The thing is, using older components with, especially if they don't have an active project behind them, can really be quite a heavy burden in your company's productivity. Well, for better news, sourcing and inspection of components is improving year over year. So one of the tools that we work with heavily is artifact repository managers. Our company produces something called the Nexus repository, and what the artifact repository manager does is it acts as a warehouse within that supply chain. So as components are being downloaded, the first step of inspecting your supply chain is to have a snapshot or a warehouse view of what are we actually using. The good news in that sense is that the usage of binary repository managers has been increasing almost exponentially year over year over the last 5 years or so. So we came to market with Nexus well into the noughties, and ever so slowly and surely we've started seeing huge mass adoption for this particular type of tool. nowadays we have 125,000 installations of Nexus, so we've actually crossed that border. These numbers come from the 2016 report. But the more encouraging news is there is a new trend in Nexus repository instances that not only exists, but also have something called the repository health check turned on. So one of the features that come in Nexus repository is that you can actually health check the contents of the things that you are downloading and get a view of the risk that you're having. And we're seeing this kind of healthy adoption of companies being more aware that some of the components that they might have downloaded might have some risks. So the fact that this kind of health check line almost parallelly mirrors the lifeline of the repository usage itself suggests that companies are catching up to the need to quality control these sorts of things. 65. The truth is, when we looked at companies, we found that 65% of them did not have any meaningful controls over what components went into their applications, and only 35% of them had some sort of way of tracking all of the different components that ended up into their applications. Something called the software bill of materials. Now, that bill of materials is quite an important piece of documentation that companies should be producing, because 1 in 5 companies had a suspected breach related to an open source component in the past 12 months when we looked at 1,300 different companies. So that means 1 in 5 intrusion suspicions actually didn't come from their own code. It came from these third-party components. For example, as an example, one of these third-party components that is relatively insecure is something called Bouncy Castle. In 2007, it had a really massive security vulnerability that was discovered that instantly got the highest possible exploitability numbers and scores out there. Well, in 2016, when we looked at that old version of that component that had the vulnerability, 9 years later, we found out that these vulnerable versions, that by this time were 9 years old, and a patched version had been out there for a long, long time, had been downloaded 11 million times. Well, more recently, there was something called commons collections, which is a fairly common component that is being used in the software ecosystem, and it had a high-profile vulnerability in the November of 2015. Well, we found out that in 2016, commons collections was downloaded 23 million times, and almost 80% of those downloads were actually of a vulnerable version. There is a patched version of commons collections out there, but only about 20%, 22% of them, of the downloads of this component were of the non-vulnerable newer version. More alarmingly, very recently there was a vulnerability that was documented in something called Struts, which had a lot of issues as well. In fact, the Canada Revenue Agency had to turn their website offline because the vulnerability in Struts is fairly easy to exploit and hugely well spread. In fact, almost 3,000 organizations downloaded vulnerable versions of Struts last year. Well, governments and various different companies are trying to enhance this national cybersecurity. There are various different pieces of legislation that try and say that that our components or applications should come with a kind of nutritional label for the various different technology products and services that they incorporate into their systems. The truth is, more and more as these kind of third-party components become part of our ready-made products, we are even the legislature is starting to expect that you provide a list of what these ingredients and projects were that made up your final product. Well, this is not only an application security issue either. Security was also a top concern when companies were thinking only about containers. 88% of the respondents in the DevSecOps survey agreed that security is a concern when they deployed containers. However, most of them did not were starting to leverage some sort of security products in to understand, vulnerable applications or operating system packages or configuration files in their containers. But still, half of them didn't. So we're still kind of in that inflection point where our companies are starting to do something to make sure that the Docker container that they download doesn't have an old version of OpenSSL or something like this. But there is still a long way to go. And the truth is, one of the other wisdoms that Deming gave out in his book back in the day is that improvement of the process also has to include better allocation of the human effort. So we cannot just run all of this on muscle and brain alone. The only way we can really solve these massive problems across the entire software supply chain is to introduce automation. Well, the good thing is, when we started asking about this question, we saw that security is predominantly being automated during Q&A and testing and prior to release and into production. And the top performing companies had a few top different tips that they started doing that helped them move faster. First of all, most companies that performed the best empowered the developers from the very beginning. They gave out tools and inspection utilities that allowed their developers to actually remediate the most pressing issues. So here you see an example of one of these intelligence screens that a developer might see, and they can actually see an entire release history of the component, and those little triangles there on the right hand side actually illustrate to the developer which versions had a known security vulnerability. So if they can spot a potential problem on day number 1, they don't have to get snagged on that in a penetration test. Research says that that's going to be 100 times faster to fix during development than it is going to be if you discover it late in production. The second thing is, all of these security and governance considerations were most effective when they were designed to be a frictionless approach. Developers live and die by CI and CD and their tests completing successfully. So the most effective methods of introducing these kind of supply chain controls were when you could introduce them into developers' every single day lives, for example, as a part of a test suite that runs in their CI and CD environments, things like Bamboo or Jenkins. Now, the greatest companies out there also went into the habit of creating a software bill of materials. Like said, the software bill of materials is a list of all of the components that were in your application, and show you which components are the worst. So here's an example. You can actually generate your own if you go to the link that's shown at the bottom of the screen there. Essentially, the software bill of materials is just a list of all the components that are out there, so that if you do have a problem, you can then refer to this and actually find the applications that had in their own bills of materials that bad component. So instead of you reverse engineering your apps to find out which components are in there, you have listings of things that are out there. If you're interested, go and give it a go. I'm pretty sure that you're going to find something that hasn't already been discovered in there. Well, that's pretty much the end of my presentation. I hope that you've learned something here today. But if I'd have to give a closing thought, it is that automating software production is something that's going to be more and more on everybody's lips. But it has to be done in a way that is empowering to the developers. Just as the Deming quote said earlier on, quality cannot be built into a product by inspection. Instead, you have to build quality into the product throughout its lifetime. So these lessons that we've learned from these companies really help us see that in order for us to survive in this new age of applications and in this application economy, the best performing companies find problems early, empower the developers to fix them, and keep track of the things that they're using in order to make sure that the 90% of their applications is safe. Well, thanks very much. If you have any questions, feel free to send them over for the webinar system, and we shall get back to you on answering them. Thank you.